Timber, as a natural material, exhibits unique deformation characteristics under load. Eurocode 5 provides guidance on how to account for these deformations using the Deformation Modification Factor. While the modification factor, which we talked about in last week's video, adjusts the design value of a strength property of timber, the Deformation Modification Factor accounts for its deformation characteristics. Over time, timber deforms under sustained loads, a phenomenon known as creep. The Deformation Modification Factor is used to predict the long-term deflection of timber elements under load. In this video, we'll explore what the modification factor is and why it's important in safe and functional timber construction. The Deformation Modification Factor is split up into two main types of deformation: instantaneous deformation and creep deformation. The total deformation is the sum of these two components. The Deformation Modification Factor, kdef, is used to account for creep deformation in timber. Its value depends on the surface class of the timber element, which we discussed in our previous video on surface classes. This is because timber's deformation is strongly influenced by moisture content and environmental conditions. Here are some deformation modification factors for three main timber construction materials and various surface classes. These values increased for higher surface classes, reflecting the greater potential for creep deformation in more humid environments, such as indoor swimming pools or poorly ventilated bathrooms. Applying the Deformation Modification Factor ensures that engineers account for the long-term deflections of timber structures, helping to prevent excessive deformations that might compromise both functionality and safety. Predicting these deformations is essential for multiple reasons. From a serviceability perspective, significant deflections can lead to discomfort for building occupants and may also cause damage to non-structural components, such as finishes and partitions. In terms of structural integrity, large deformations can introduce additional stresses, increasing the risk of failure. Aesthetically, visible sagging or bowing detracts from the appearance of the structure and may diminish its perceived quality. Furthermore, unexpected deformation can lead to costly repairs, retrofits, or legal disputes, making early and accurate prediction a key factor in managing long-term project costs. The Deformation Modification Factor is an essential tool in the timber designer's toolkit, enabling engineers to account for the time-dependent behavior of timber under varying environmental conditions. By incorporating it into design calculations, designers can ensure that timber structures not only meet the strength requirements, but also maintain their shape, functionality, serviceability, and safety over their intended lifespan. For more on how environmental conditions affect timber properties, check out our video on the surface classes. And to understand how load duration impacts design, see our video on the load duration classes.
Stay informed, stay inspired. TimberTalk.